Imagine the universe has an edge. Not a wall, not a border, but a place where space itself begins to change. Where distance stops behaving like distance, and the rules we trust simply dissolve. Now imagine the first telescope capable of seeing back to the dawn of time, finding something that shouldn't exist. Something so early, so massive, so impossible, that the story we built infinity on suddenly cracks. Because if the beginning of the universe was stranger than we believed, how certain can we be about the rest of it? For nearly a century, our cosmic map has relied on one elegant idea. The universe is flat. Not like a page, but in the geometric sense. A universe where parallel lines never meet. A universe that stretches forever. And from that flatness came a simple assumption. If it isn't curved, it must be infinite. That idea didn't come from philosophy. It came from the oldest light we've ever seen. The cosmic microwave background, the faint afterglow of the Big Bang itself, still glowing 13.8 billion years later. A pattern that suggested a universe without edges. Infinity wasn't proven, it was inferred, built on a model that said the early universe was simple, small galaxies, slow growth, predictable expansion. It was a comforting certainty, until James Webb turned on. Webb was supposed to confirm our story. Instead, it found galaxies that shouldn't exist. Galaxies from just 300 to 500 million years after the Big Bang. Massive, organized, aggressively forming stars. Some blasting out hydrogen light so bright it pierced the fog of neutral hydrogen that should have smothered it. One galaxy was glowing with impossible clarity, light breaking through cosmic fog that should have blocked it completely. Another hosted a black hole that seemed too powerful for a universe that young. The early universe wasn't gentle, it wasn't slow, and it wasn't simple. It was chaotic, fast, efficient, structured. And nothing in our neat models predicted any of this. If the beginning of the universe was wrong, then the conclusions built on that beginning might be wrong too, including the assumption that space goes on forever. Infinity was our safest idea. It freed us from worrying about limits, boundaries, endings. But Webb didn't just reveal strange galaxies. It revealed a pattern. And that pattern cracked the foundation we built infinity on. And for the first time in decades, infinity wasn't guaranteed. At first, scientists tried to explain it away. Maybe Webb just misread the data. Maybe the early galaxies weren't as massive as they looked. Maybe their distances were overestimated. Maybe calibration issues distorted the results. But follow-up spectroscopy confirmed everything. These galaxies really were old, really were massive, really were bright. So they tried again. Maybe we misunderstood how galaxies form. But that explanation didn't work either. Because the anomalies weren't isolated. Star formation too early, black holes too massive, structure appearing hundreds of millions of years before it should. The problem wasn't the data. The problem was the story we'd been telling. Our belief in an endless universe wasn't based on direct observation. It was based on the assumption that the early universe behaved predictably. Webb shows it didn't, which means infinity is no longer the safe assumption. It's just an assumption. The question is no longer, did Webb discover that the universe is finite? It becomes, what if we were wrong about the most comforting idea we ever had? So now we can wonder, if the universe really does have an end, what would it be like? Imagine you could travel there, past the cosmic microwave background, past the farthest galaxies Webb can see. You'd keep going and going. Galaxies thinning out, stars growing sparse, the temperature dropping toward absolute zero. Until finally, you reach it. But what is it? Maybe there's no edge at all, just geometry that loops back on itself. Like an ant walking across a sphere, you'd travel forever in a straight line, only to return to the place you began. A universe that's finite, but boundless. Or maybe you'd reach a place where the rules change. Not a wall, a transition, where our universe presses against another, a membrane between realities. On the other side, different physics, different constants, maybe even different dimensions. Some physicists think our entire universe might be inside a black hole, that what we call the Big Bang was matter collapsing in some larger cosmos. And beyond our edge, other black holes, other universes. A cosmic archipelago of pocket realities, each with its own laws. Or maybe beyond the edge is simply nothing. Not empty space, not vacuum, just non-existence. You reach out your hand, and it doesn't stop, it doesn't pass through, it simply isn't anymore. No one knows which is true, but for the first time in decades, we're asking. And questions this big don't just change our models, they change us. Here's the truth. The James Webb Space Telescope did not find an edge. It did not prove the universe was finite, and it didn't break the Big Bang. What it broke was something deeper, certainty. The early universe wasn't what we thought. Our clean, orderly models were incomplete. And infinity, the idea we used to fill the silence, was built on top of those models. The edge of the universe wasn't discovered, but that possibility is alive again. We used to think the universe was infinite because infinity was simple, comforting, clean. But Webb revealed a universe that is anything but simple, chaotic, fast-growing, uneven, unpredictable. A universe whose beginning we don't fully understand, and therefore a universe whose shape we can't assume. Infinity may still be true, or the universe may be finite in a way we've never imagined. For the first time, both possibilities are genuinely on the table, and that changes everything. We love the idea of an endless universe, because infinity means there's always more. More space, more time, more possibilities. But there's a hidden cost to boundlessness. If nothing ends, choices lose their weight, stories lose their shape, life loses its urgency. A universe with an edge, even a distant, unreachable one, gives everything inside it a frame, a boundary, a meaning. Maybe that's why we're drawn to the idea that the universe could have an end. Not because we want it to, but because deep down, we know that meaning lives where things are finite. We don't fear the edge of the universe. We fear the edge of meaning. Because infinity promises us endless tomorrows. But the things that matter are the things that don't last. Maybe the universe doesn't need to be endless to feel whole. Maybe it just needs boundaries that turn the vastness into a story. And maybe the truth is that endings are the only places where meaning can live.